All right, we're going to do quadratic translations. Okay? Now, with quadratic translations, I've actually drawn this in standard form. That's fine. We're used to seeing things in standard form. What we're going to be looking at, okay, this is our standard form. We're going to be looking at things in vertex form. Vertex form is y is equal to ax minus h squared plus k. Okay? Now that's where we put all three of the variables h, a, and k together to move our parabola. Now, we have previously worked with h, k, and a. We worked them individually. Okay? We individually learned that h did horizontal translations, k did vertical translations, and a flipped the parabola. It would flip our parabola, or it would stretch it, or compress it. Okay, the other one was supposed to be a stretch. Now, you were given questions similar to this on the quiz, and you could have solved those on the quiz by using a chart, x and y, plugging in x values, maybe like -2, -1, 0, 1, 2, and finding the y values and plotting the points until you got some type of parabola. Okay? What we're going to go today is we're going to be able to look at the entire vertex form, so all three of these variables having numbers representing them, and being able to just draw that parabola. Okay? Not technically, no. So, if you already knew how to do that on the quiz, you're ahead of the game, which is good. So, first thing I want you to do is, what type of parabola do we need to know how to draw?
Quadratic.
Yeah, but what's this one? This is the parent function, okay? Y equals x squared. I'm going to draw, or I'm going to write this equation in vertex form with actual numbers for a, h, and k, okay? And the reason I'm going to do this is so we can really make sense of why our original one is sitting the way it does. We have y is equal to, we have x minus plus. Okay, our a value here is 1. Our h value is actually 0, and our k value is 0 also. Now, what's important is our h and k values actually tell us the coordinate of the vertex. The vertex of any of our quadratics is written when in vertex form, right in the question. So our x value and our y value are essentially just the opposite of the h value, so I'm going to say negative h, and whatever the k value is. Okay. So for our original, what's my h value? Yeah, technically it's a negative, right? So what would be opposite of negative? Positive. But negative, positive, 0 is the exact same number. So our x value of the vertex is 0, and our k value is also 0. So the y value of the vertex is 0. So the vertex of the one we're used to drawing is at 0 and 0. Makes perfect sense. Okay. Then when we go to draw this, we talked about stretches and compressions with a. Well, this a is positive, so we know it's going to face upwards. And we know that whatever we move over by, we have to multiply by our a value. So let's think about this. Normally, I put it in a vertex, I move over 1. How much do I go up? 1. We square it. Well, what is 1 times 1? Still 1. Didn't make any change, right? What if we went the other direction? Negative 1. What is negative 1 squared? Yeah. And then times 1? Still 1. Didn't change anything. So I want you to get used to this idea. For instance, let's go over 2. Okay. Oh. Oh no. Try that. So like we were saying, if we were to go over 2, we go over 2, how many should we go up? 4, right? And what would 4 times 1 be? 4. So if you notice in our original one, it doesn't change anything. So we draw what we're used to drawing, and 3 is 9. This is our parent function. And when we talk about translations, we're always talking about moving from this one here. Is that, oh, sorry, I drew it at 3. It should be at 4. Thank you. Okay? There you go. So, with that being said, I'm just going to show you now, if I were to expand this, well, what is x plus 0? No? X, good. And then we have x squared. And then plus that 0 doesn't make a difference. X squared is x squared, and times 1 is just x squared. So that's how this function here turns into our parent function. It actually has values for h, k, and a. We just really don't write them in because they're assumed to be 0, 0, and 1. Now, let's actually draw or write an actual equation here that we'd have to graph using the information. So let's say we had negative quarter x minus 5 squared, and then we're going to say minus 2. Okay. Now, the first thing I want you to recognize is in vertex form, which values are our h, which are our k, and which is our a. So what is our a in this instance?
Quarter.
Negative a quarter. Okay. What would be our h? Okay. Yeah, 5 or negative 5. And what would be our k? Negative 2. Good. So we already know by looking at the h and the k, we can figure out what the vertex is. What is the vertex of this going to be? It's going to be negative 2, but it won't be negative 5. Positive 5, right? Remember, our h is always counterintuitive. Okay, so in this case, we're going to have positive 5. So let's go back up to our graph. We know we're going to go over to positive 5 and down 2. So this is where the vertex of that parabola is going to start. The only thing we have to do from there is draw it. Now here, in this case, our a value is negative a quarter. So we have to apply that when we're moving. Normally, we'd go over 1, square that, up 1. What is 1 times a negative a quarter? Negative a quarter. So we actually go down a quarter. Same with the other direction. It's symmetrical, right? Then we go back to the vertex. We go over 2. How many do we normally go up? 4. What's 4 times negative a quarter? Negative 1. Okay? So negative 1. There we go. So what that means, we go over 2, down 1. 3. If we were to go over 3 units, we'd normally go up 9. 9 times that becomes 2 and a quarter, or negative 2 and a quarter, so we go down 2 and a quarter. And if you notice, this parabola is far wider than it was before. Let's actually continue it. If we were to go over 1, 2, 3, 4 units, 4 would be 16. 16 times a quarter is what? 4. 1, 2, 3, 4 units. And then if we were to go over 5, 5 is normally 25 times a quarter is 25 over 4. Anyone know what that is?
Looks like 25 over 4.
6 and a quarter. So that's 5, 6 and a quarter. Okay, so we got 6 and a quarter. So if you notice this parabola, we were able to fit quite a few more onto this. Of course, that's going to happen again. So just like we were saying before, this parabola is going to be wider than the one we're used to seeing. So, when looking at this, you should be able to actually find the vertex and plot the coordinates of the rest of the parabola just by the variables a, h, and k when in vertex form.